This is Chapter 5, Problem 16. In this problem we have a bug. I think Mr. Yinger probably really likes this problem. We have a bug that is hanging off of a rod. And this bug has 6 legs, and each one of these legs is going to be attached to the rod, and each leg is going to support his mass. Now, since he has 6 legs, that means that the force of gravity on the bug is going to be divided 6 different ways. So the force of gravity on the bug typically would just be mg. But since we have 6 legs, we need to divide mg by 6. That becomes the Ty component. If you look at the drawing on the left, you have the tension in the tibia at an angle of 40 degrees. Now that tibia, that tension, is going to be at an angle and give us an x and a y component. All of the x components are going to cancel out. Since he has legs on both sides of the rod, you're going to have equal and opposite forces, and thus no net force along the x direction. This better makes sense, because otherwise the bug would start to move in the x direction because he would have a net force. Along the y direction, the Ty's are going to cancel out his force of gravity down. Since he has 6 legs, each one of those Ty's is going to be equal to mg over 6. So Ty is equal to mg over 6. Ty is also equal to T multiplied by the sine of 40. So now we substitute and we have mg over 6 is equal to T sine 40. And we want to solve for T in terms of mg. So that's going to be mg over 6 over the sine of 40 is equal to T. Finishing up the math on this problem, we now have T is equal to 0.26 mg, and that is the ratio between the tension and the force of gravity, or the weight, on the bug. For the last part in the problem, it asks if the insect straightens out its legs somewhat, does the tension in each tibia decrease, increase, or stay the same? So that means that theta is going to increase. Now if we look at that triangle again, we have the hypotenuse, and then we're going to have the angle. As the angle increases, the y component, Ty, is going to increase. The y component is going to increase. So more directly, the y component is going to hold up the force of gravity. And what that means is that the overall tension is going to decrease. Okay? You have to think about that in terms of the hypotenuse. As his leg straightens closer and closer to 90 degrees, then that means that the hypotenuse T is going to get very, very close to just Ty. If you have Ty and Tx, if Ty and Tx are 2 values, then a squared plus b squared equals c squared, and that means that the tension is going to increase. So be careful on that one. As the angle increases, the tension is going to decrease.